or functions in C. But there's a little bit of a difference in C++. It just takes it to the next level, which I kind of like. There's a lot of well, pun right there, functionality and functions. But there's a lot of things you could do with functions in C++ that you can't really do in Java or C. So let's take a look. Right here you'll notice I have a main, which is pretty common to you right now, and I have some variables declared, some integers double floating along, and I give them some values right there. But let's go ahead and talk about the basic function. And right here, this is a basic function, and so is this. Both of these functions do two different things. This function has a declaration right here and the body of the code. And what it does is that it takes in two parameters for this function. Now in the header of this function, you notice that we have a void, find max, and two integers. So let me explain what this is. The void represents the return type. If you want to return something back to main when it's called, you would have the type right here. For instance, we have void here, so therefore we're not returning anything. So if I had int right here, then I would have to return some kind of integer value, max num in our case, where max num was the integer I declared inside of here. But for our purposes, we're not returning anything. We're just having it return nothing. Now in the body of the code here, this return needs to match whatever we're returning. We have void, so I could just hit return and semicolon, and that'll be appropriate because we're not returning anything. And like I showed you, when I change this to an int, I have to return an int down here. So I could either do it this way, or if you noticed in this other method, I didn't have a return, because you could either do it type return or not type return. But if you actually do have to return something like an int or double or whatever else you need to return, or float, then you would actually have to put something down here that says return and the following variable that represents the return type up here. Now the next line is the name of the function, which I named this find max, and I named this one print me. And inside of the parentheses is your parameters. In this case, this one's taken in two parameters, two integer parameters right here. Or down here in print me, this one doesn't take in any parameters. So in C++, you could do it one of two ways. You could either type in void, or you could just leave it blank like this. So either way is fine. Either way will work. So this is a little bit different from C and Java, where you cannot really type void in, but you could type void in here for C++. Now, just like Java and C, there's the body of the code right here in the middle. And this one determines the maximum integer out of two integers that was passed in, and it actually just doesn't return anything. It just prints out which one the maximum one was. This one just gives a print statement of you can use void or nothing in the parameter list, just to demonstrate this void that I have here. Now in main, you notice that I call the functions like you normally would do inside of C or Java, and by using find max and inputting two integer values, and it passes it into here. Now it passes by value, so x will get, I believe, 5. Yep, x will get 5 and y will get 6. And inside of here, it'll determine what max num is based on which one's larger, and in this case it should be 6. And the void print me, you could use void or nothing in parameter list will print right after this. So let's go ahead and give it a shot. And you notice that the maximum value of the two numbers is 6 because I passed in 5 and 6. And then you can use void or nothing in the parameter list, which is right here for print me. Okay. Now, This is very useful and something you probably are very familiar with. Okay, but let's get into those topics that you're not really familiar with. And one of those topics is called default function calls. Now you notice this has the same name, but it has different arguments in it. And you're thinking, okay, maybe it's like method overloading or something like that. Well, no, that's not the case. Oh, actually, let me step back here for a second. Rewind. Sorry. You'll notice that find max and print me are up top right here. And that's the reason why is you can't use find max and print me without declaring them first. So like C, where you have to put your functions on the top, you can actually just put find max and print me above main up here, just copy and paste it over, and you wouldn't need these two headers right here. But in order for you to read C++ code effectively and to use all of what C++ has to offer, you should really try to declare the prototype on top first and then declare the functions underneath. And the reason that is because you'll notice that I have a bunch of functions that I need to have prototypes for up here, and you'll know right away for easy reading what kind of functions they are, what did they pass in, and it'll keep it nice and clean and easier to read. Also, when you're putting all a bunch of functions in here, you could easily accessibly look and see all the different names right up here. Also, there's something called templates, which we'll look at later in this tutorial, that we'll have to look at, and that has to be put up here, and it'll keep it away from these other functions, and it'll be just for easier reading. So keep in mind, I could have copy pasted the function and put it right on top and not have to create these prototypes, but I did create these prototypes so I could use it for easy reading and better functionality. So find max, you would do it just like you would declare the method, but except you would just take what the return type was, the name of the method, and what it took inside. In this case, it took in two ints, so I write the int and int, and then a semicolon. Same thing with print me. The return type was void. That's the name, and it doesn't take in any parameters. Okay, good. So now that we've done that, I'm gonna provide a prototype for UseDefaults, and you notice that in the I actually declared some values in defaults, and this is where it becomes helpful for you to declare the prototype first. Okay, sometimes you have some values for a method, for a function, but sometimes you don't, and this is where this comes into play. Default function calls. I could create a function that could use default values or use values that you have to override them. So this UseDefaults prototype, I declare in the top, void, return type, UseDefaults. I declare that I want 3 integers inside of this prototype, and I give them values. I'm going to give A the value of 2, B the value of 3, and C the value of 4. And down here, A, B, and C, typical method, I'm just going to print them out, A, B, and C, and end the line right there. And the trick is where you call this particular method right here with this default arguments. Let's go up to main and see if I can keep that. Yep, I can keep both of them in view here. You notice that I call the UseDefaults function 3 times, each time a different way. One time I called it with no arguments in it, and what would happen is it would call the method, call the function UseDefaults, and since I didn't put anything in the list, it will use these values for A, B, and C, because I didn't I didn't declare any values to put inside of the function. The second time I call it, I put in 7. So what would 7 do? 7's actually going to replace the first integer it sees right here, and it's A. So A will get 7, B will remain at 3, and C will remain at 4. The third time I call it, I use 7 and 8, which means A will get 7, B will get 8, and C will remain at 4. So let's go ahead and run this again, and I will show you what I mean. There's crazy stuff. Okay, so the first time I called UseDefaults, remember UseDefaults, all it does is print out A, B, and C. It prints 2, 3, and 4. 2, 3, and 4, because I didn't put anything inside of the function call. Now the second thing I did was I replaced one of them with a 7, and it replaces the first one, which would be A, 7, 3, 4, and 7, 3, 4. The third time I called it, I replaced A and B with 7 and 8. So 7, 8, 4, 7, 8, 4, because it replaced A and B and left C alone. So that's actually a good way of using a function that sometimes has some values already in it that you could use for default values in case you don't want to override them. But sometimes you can and sometimes you won't. So this is actually a very useful function that's not available in Java that can help you with your code. Now here's something that might be a little familiar with you for those of you who already taken Java. This is called my overload function and my overload function calls. What it is I have the same function name, but it'll take in different parameters. And let me show you what I mean. It's called my overload function for every single function, but one takes in 2 integers, one takes in 2 doubles, one takes in 2 floats, and one takes in 2 longs. And each one do the same thing. So usually for uniformity's sake, if I need to use an overload function to sum up 2 digits, and they do the same body of code, by standard practice you would name it the same and just build an overload function, meaning just change the parameters right here, and you could use the same name over and over again as long as the parameters are different. Okay, so if once you change the parameters, then C++ will be able to figure out which one you actually mean when you call for it, because it's using the parameters to fit into the one that it's most likely going to be calling. So in our case, we have some ints, doubles, and floats declared up here, and the first one I put in is 2 ints. These are 2 ints. So it looks down to the bottom, and it looks to see which one it could fit into, and look, there's one with 2 ints. So it'll call this overload function because it has 2 ints. It won't call the double or the float one or the long one, because this one is what it looks to find, 2 ints. And it's the same for the rest, the double, floats, and the longs. It'll all call its appropriate method because it'll look to see, even though they have the same name, to find out which one of the parameter lists makes sense to it. Show you that, and you'll notice that 10, 10.5, 10.5, and 1110 are your answers right there for adding the 2 digits together, which you could see the values up here, and you could check the math if you like, but I'm pretty sure the computer added them correctly. So that is method overloading. And the last thing about functions we're going to talk about is something called a template. Now you must be thinking, wow, this is crazy. We had to do this several times and it was the same body of code. Can't we do this kind of generically for my Java people and generically for my C people maybe? Well, there you can. You can actually do this generically. And that's something called a template in C++. What you do is, I'm going to go ahead and I'm going to create something called this template right here, which will add the 2 numbers that are passed into the function just like we did down here, but without creating a different one for each type. So how do we do that? Well, it's pretty simple. First of all, I have to use this keyword called template, and it has to be declared on top here, and template class mygen. Alright, Now let's keep on following with me right here. What myGen is going to do is that it's going to become like a generic type. And I'm going to use it inside of the function and replace what myGen with whatever type you actually pass in. So that gets a little confusing, so let me go through it. myGen is like a generic type. So it's using the template the template that's built into C++, and you declare the template class myGen, and you could just myGen could be anything. It's just a name, and what it is that the return type is going to be a type myGen, and the two variables are going to be of type myGen, and type myGen right here declares C. So you see a pattern right there. So let's take a look at what we did with one of these int overload functions. You'll notice that here these two are ints and this one was an int right there. So if I happen to call an int with the template, which these two ints are 12 and 34, it'll automatically or automagically replace myGen with an int. It'll automatically replace myGen with int is the return type, int. So anywhere it saw myGen, it's going to replace it with int. But why? Because the template, when I called it, is passing in two ints right here. So when I pass it in, it'll automatically change myGen to return to a type of int. And since ints are C, it's going to add the two integers together and then return an int right there back to sum, which is an int. Okay, this is the part where you have to actually know what you're calling at this point, because when you're returning an int, you have to assign it to an int. So I knew it right there. I put it to an int right there. So these are two integers. Now, if I were to say, for instance, template example, and put into floats like ff and fs, and let's go ahead and declare a float, some float, and some float, declare it there, see out, line, just a float and line. There we go. Let's go ahead and see if it works. So we use the same method twice, once for an int, once for a float, and then it's calling it, but it should add them together. Now you notice I didn't have to create a separate one. We're using the same function, right? So let's go ahead and run this, and boom, it gets 46 for, there we go, 46 for the sum of 12 and 34, which is correct. And you notice I called temp example again, and I added the two floats, which is 10.5. And I didn't have to do the overloaded function that we've been doing down here. All this extra code that we had to type, and you know, it's really strange. You get carpal tunnel typing all those methods. Just kidding. You know, I just copy pasted and then changed the types. You know, I just wrote this function first, copy paste, copy paste, copy paste, then I just changed it to double. But you know, but still, you know, it's still a lot of time wasted by writing the same function over and over and over again. Where you could just create a template for each one because they all behave the same. It's just that the type has to change each time, and that's when you create this little template and call it myGen, make it myGen a template, and what it does is just be replaced by whatever you're calling it based on the parameters, which is right here. Here, the first time it calls an ints, the second time it calls floats. So it'll change myGen to an int the first time, and then myGen to a float next time. Okay, and that is very powerful, very, very powerful in C++. Okay, so to go over a review, make sure you declare your prototypes at the top. It's for easy reading, and also it helps you later on in your code, like for instance when you use defaults. you declare your prototype at the top with the defaults, and then you use your default function down here. Okay, so it's a little bit easier, keeps it nice and clean, and it also helps you out with your code later on. And like I said, you can still copy paste it above main, but this is the best way to do it. Click declare your prototype, be professional, declare your prototypes, and then make your functions down at the bottom here, and then your templates on top of here as well. Okay, and I hope this was helpful, and I'll see you in the next tutorial.